Let us take one more example on the solution of non-homogeneous system of equations. Here we'll consider a set of three equations in three unknowns x, y, z. X plus y plus z is equal to 6, x plus 2y plus 3z is equal to 14, and x plus 4y plus 7z is equal to 30. So here there are three unknowns x, y, z and three equations. So the coefficient matrix A is of order 3, in which first column is coefficient of x, that is 1 1 1, and second column is coefficient of y 1 2 4, and the third column is coefficient of z, that is 1 3 7. Now to solve this set of equations, we write the augmented matrix AB, that is, along with the coefficient matrix we consider one column of constants. So we write in the first row the coefficients of unknown with the constants, that is 1 1 6, and in the second row we take 1 2 3 and 14, and in the third row 1 4 7 and 30. We have to reduce the augmented matrix to the echelon form, that is, if we take a conceptual line leading from the first non-zero element A11, the elements below this line, if we take a conceptual diagonal line from the non-zero element 11 A11, the elements below this line must be 0. We don't bother about the remaining elements, so we retain A11 and remaining elements in the first column will make it as 0. So we apply R2 minus R1 and R3 minus R1. So we have first row as it is 1 1 6. In the second row changes, second row R2 changes to R2 minus R1. So 1 minus 1 is 0, 2 minus 1 is 1, and 3 minus 1 is 2. The constant 14 minus 6, that becomes 8. Similarly R3 minus R1, that is R3 is changing to R3 minus R1, 1 minus 1 0, 4 minus 1 3, and 7 minus 1 is 6. 30 minus 6 is 24. So in the second step we retain the second column A22 element and make the remaining elements below A22 in the same column as 0. That is, we need to make the element A32 3 as 0. So we take R3 minus 3R2. That is R3, the third row is changing and it is changing by R3 minus 3R2. So the first row as it is in the AP matrix 1 1 6, the second row as it is 0 1 2 8, but the third row is changing, so it is R3 minus 3R2. So the first element is 0, the second element is 3 minus 3, that is again 0, and the next element is minus 2 into 3, that is minus 6, plus 6, it is again 0. Then minus 8 into 3, that is minus 24. Then add it to the third row element 24. So 24 minus 24 is 0. Now the AB matrix. Now if we consider the matrix AB matrix, that is first row 1 1 6, and in the second row 0 1 2 8, and the third row is the 0 3. So it is in the echelon form. and here in the A part there will be 2 non-zero rows, and in the entire matrix AB part again there will be 2 non-zero rows. So rank of A is equal to rank of AB is equal to 2, but this common value 2 is less than the number of unknowns, that is 3. So we have to decide free variables. If there are n unknowns and the common rank of A and AB is R, then n minus R variables will be free variables. So here there are 3 unknowns and the rank is 2, so 3 minus 2 is equal to 1. So we decide 1 as the free variable. So let z be the free variable. Free variable in the sense it may take any value. Of course, if we take 0, then all the variables will take 0 value depending on the free variable. So we should not take 0, but other than 0 we can consider. Other than 0, it may be any value. That is, we let z is equal to k, where k is a constant and not equals to 0. Then from the second row, we get the reduced equation, that is y plus 2z is equal to 8. You may note that the elements in the second column are coefficient of y, the elements in the third column are coefficient of z, and the last column is constant or RHS. So from the second row we can write the second equation as y plus 2z is equal to 8. From this one we can write it as y is equal to 8 minus 2z, or this is equals to 8 minus 2k, as z is equal to k. And from the first equation we see that x plus y plus z is equal to 6, or we have x is equal to 6 minus y minus z, and substituting z is equal to k and y is equal to 8 minus 2k, we can write x is equal to 6 minus 8 minus 2k minus k. So this is equals to, we have k minus 2. So x value is k minus 2, y value is 8 minus 2k, and z is equal to k. So with these values it forms a solution set for the given system of equations.